Welcome to solverfy.
So we're going to try to find the velocity as it hits the Earth's surface fallen from a height above Earth's surface. So we can say that force equals ma, and this will equal negative g times the mass of the Earth times the mass of the object divided by r squared. So we can cancel out m, and we find that the acceleration felt by the object will be equal to negative g, the gravitational constant, times the mass of the Earth divided by r squared. And so at this point, this is going to be equal to dv over dt. That's simply the definition of the acceleration. And then we can use chain rule, so dv over dr, and then times dr over dt. At this point, we know that this is going to be, that a is going to be equal now to v dv over dt. At this point, we can say that this is equaling negative gme over r squared. And we're going to say that negative g times the mass of the Earth divided by, rather, multiplied by dr over r squared will equal v dv. So my apologies, this actually is v times dv over dr. That was an error on my part. My apologies. So this would be v times dv over dr. Now, at this point, we can say that we can actually integrate and say that negative g times the mass of the Earth times the integral from 2 times the radius of the Earth to the radius of the Earth of dr over r squared will equal 0 to the velocity final of velocity dv. And so let's get a new workbook. We can say that the gravitational constant times the mass of the Earth divided by r squared, evaluated at 2 times the radius of the Earth to the radius of the Earth. This will equal the velocity final squared over 2. And so we can say that gm sub e over r sub e will equal gm sub e over 2r sub e, and this will equal v final squared over 2. And so v is going to be, v final will be equal to radical g m e over r. So essentially the exact same thing as the formula for the velocity of a uniform circular moving object. However, here we derived it from integration rather than algebra. And here it's going to be negative because we have chosen that the object is moving, negative direction is chosen because the object is moving towards the Earth's center, and we chose the outward radial acceleration to be positive. So the final velocity could be plus or minus, but we're going to specifically choose the negative option. So this will be our final answer. That is the end of the solution. Thank you for watching.